Hello and welcome to this video in which I address the question of whether you can calculate the parameters in a factor analysis or structural equation model by hand. My name is Geiser. I'm an instructor and statistical consultant with QuantFish, and on this channel I present weekly statistics tutorials. On Tuesdays I typically present an analysis in the Mplus software, and on Thursdays I address more general questions in multivariate statistical analysis, including structural equation modeling, factor analysis, multi-level analysis, and latent class and mixture modeling. If this is something that interests you, then please subscribe to this channel. Also, don't forget to hit the like button and to check out the description for additional free resources, including a link to my weekly statistics newsletter as well as free courses that I offer through QuantFish. In this video, I want to talk about an issue that sometimes comes up when people start using structural equation modeling or confirmatory factor analysis. They often wonder whether they could calculate the parameters of a factor analysis model or structural equation model by hand. For example, factor loadings, factor correlations, path coefficients in a structural model, and other parameters. And so the reason why people wonder that oftentimes is because they are used to so-called conventional statistical methods such as analysis of variance, multiple regression, where you can, in principle, sit down and compute the regression coefficients or the F statistic in an ANOVA, an R squared, and so on by hand. Now, the question then is this also possible with factor analysis and structural equation modeling? For example, if you didn't have access to a computer program, would there be a way to compute these parameters by hand, or could you at least do this in terms of formulas in a program such as Microsoft Excel? That may be practical because then you may not have to learn a program for structural equation modeling, or you don't have to buy one, and so on. So there are certain reasons why people might have legitimate reasons to wonder about whether this can all be done by hand. And so in this video here, I want to give you the conceptual answer. I will not go into formulas or mathematical details, but I'll tell you, so to say, what the issue is on a conceptual level. So most of the models that we use when we run confirmatory factor analysis or structural equation modeling with latent variables, or path models also with observed variables, most of these models are so-called over-identified models, which means that they have positive degrees of freedom. They yield an overall test of model fit, a chi-square test with more than 0 degrees of freedom that allows us to test a model, that allows us to test the hypothesis that the model fits exactly in the population, and provides for the opportunity, so to say, for the model to fail. The model may be rejected if it doesn't fit. And so because models are typically over-identified, they are we're not in a position to calculate or compute the parameters of these models by hand. And so the reason for that is that the models estimate fewer parameters than there are pieces of information from which the parameters are estimated. So in order to understand that, we have to review or think about what actually serves as the basis for estimating free model parameters in structural equation modeling and factor analysis. And so what is the input? The input for factor analysis or structural equation model is the covariance matrix, potentially accompanied by a mean vector of the observed variables if we are also analyzing the mean structure. That happens, for example, when you use growth curve models, longitudinal models in general, when you use multi-group analysis to compare different groups. Then we also include the mean structure. In cross-sectional single group structural equation or factor analyses, we may not include a mean structure, and we may only look at the covariance covariance structure. And so for simplicity, so that I don't have to talk about mean structure and covariance structure all the time, for now I will assume that we're looking at the simpler case where we're only analyzing a covariance structure, although the whole issue is the same whether or not you include a mean structure as well. So let's assume that we're analyzing covariances here with a structural equation model. And so what the structural equation model then does is, in the over-identified case, is it uses fewer parameters to in the model than there are observed variances and covariances in your covariance matrix. And that's where you get positive degrees of freedom when you estimate a model that does not saturate your covariance structure, meaning there are restrictions in the model that are imposed then implicitly or explicitly on the observed variances and covariances. And so therefore, because you are not using up all the variances and covariances in your data to estimate free model parameters, there is no direct connection between each variance and covariance and your observed and your unobserved model parameters that you want to estimate. And therefore an iterative process is used for over-identified models where the parameters are found according to certain optimization criteria. And that is something that you could not easily do by hand. Instead, something like maximum likelihood estimation is typically used to estimate the parameters for an over-identified model so that the parameter estimates will be closest to your observed data while satisfying the restrictions that make your model over-identified, meaning that provide positive degrees of freedom for the model fit test. So that's the reason conceptually why you can't sit down and use a formula to solve for each model parameter, because there is no general closed form solution for over-identified models. Now, that being said, there are special cases of factor analysis and SEM where it is possible to calculate the parameters by hand using formulas, and that is when you have so-called saturated models. Saturated models are models that do use up all the variances and covariances in your data to estimate parameters such as factor loading, structural path coefficients, factor variances, factor residual variances, and so on. So then when you have that case where a model is saturated, then there is a closed form solution. That happens, for example, when you have a single factor model with 3 indicators and where the factor loadings can differ between the 3 indicators. That's a so-called congeneric model. And so if you have a congeneric model with just 1 factor and 3 indicators of that factor, then that would be a saturated model. And so you could sit down and you could solve for each of the factor loadings, you could solve for the factor variance and the residual variances of the observed indicator variables, and you would not need a computer program to give you that output. Now, of course, that's tedious to do, to sit down and think about how all the parameters relate to the observed variances and covariances and then solve for each unknown parameter, but this would be possible. And so that's to see the reason why it is also possible with models such as multiple regression models, which are a special case of structural equation or path models. And so it's possible with standard multiple regression to do that because multiple regression is also saturated. Those are all saturated models that use up all the observed variances, covariances, and means to estimate regression coefficients. And so that's the reason why this works with standard statistical models, because they are saturated. Now, with structural equation modeling and factor analysis, we typically do not use saturated models because we want to test a model. We want to have an over-identified model that does impose restrictions on the observed data so that the model can be tested. And that's one of the strengths of structural equation modeling and factor analysis, that we can estimate over-identified models that have testable restrictions for the observed data that can be falsified, that can be tested against the observed data. And so then when we have such over-identified non-saturated models, then you cannot solve for the parameter estimates by hand. And it's also in general a lot more practical to use software to estimate the model parameters, because it can get complex very quickly, even for saturated models, to estimate or calculate the parameter estimates. You can use a variety of programs for factor analysis in SEM. Some of them are free. So for example, the lavaan package in the R software would be a free package, and I offer an introduction to lavaan. You can find that mini course in the description here. It's a free mini course where I introduce to lavaan. I also have a free mini course that introduces path analysis with Mplus that you can also find in the description. I hope you found this video useful to learn more about structural equation modeling and factor analysis. If you did, then please subscribe to this channel. Don't forget to hit the like button and to look at the description for additional free resources, and I'll see you next time.